Welcome to Derivability. Here we're going to take a look at some half-angle identities for the tangent function in trigonometry. Okay, in a recent video, I talked about double angle identities for our three standard trig functions, sine, cosine, and tangent. And then we also talked about the half-angle identities for sine and cosine you see in the upper left of our screen. And then from these two, if you take sine theta over 2 divided by cosine of theta over 2, we can very quickly generate a half-angle identity for tangent. Okay. Now you may recall that the plus or minus over on the sine and cosine half-angle identities had to do with the quadrant. Okay. Whatever quadrant the theta over 2 is in, that helped us decide on that plus minus. The same is true for the plus minus over here in the tangent identity. Okay. Now, this can't be avoided for the sine and cosine identities, but for the tangent identity, it's worth asking, can we somehow circumvent the need for this plus minus symbol, possibly also the need for the square root? Okay, maybe, maybe not. Still worth asking. All right, so as you can see here, if I square both sides, I get rid of the plus minus, I get rid of the root. Now, I don't have a tangent half-angle identity. I have a tangent squared half-angle identity. Okay, but this is the starting point for generating something that does not need the root, or as we will see, the plus or minus. Okay, so let's start with what we have here. And there's actually two different identities that we can generate. Okay, so let's do this. Let's multiply both top and bottom of this identity by 1 minus cosine theta. Okay, and some parentheses here are possibly going to be helpful. All right. Okay, as you guys know, this fraction is really just a disguised version of the number 1, so we're permitted to do that. Okay, so what I have now is tangent squared theta over 2 identical to, now up top, I could FOIL that out, but I'm not going to. I'm going to write that as 1 minus cosine quantity squared. Okay, down below, what I can do is I will FOIL that out, and this actually ends up being a difference of squares. 1 squared minus cosine squared. 1 squared is 1. Okay, that's a very common sort of factorization that or product that you probably recall from algebra. Okay, if not, I would encourage you just to FOIL it out using all the steps. Okay. Okay, now the interesting thing here is that this denominator is an identity for sine squared theta. So we are at the point now of having tangent squared theta over 2 identical to the binomial 1 minus cosine theta squared over sine squared theta. Okay, and just to kind of put the fine point on it here, the right-hand side is a perfect square, as is the left-hand side. Okay, so let's take the square root of both sides. Now that kind of helps, but we still have some issues to work out. Okay, so if we take the square root of both sides, we get tangent theta over 2. Okay, then on the right-hand side, we can write 1 minus cosine theta over sine theta. Okay, but technically, strictly speaking, whenever you do this maneuver, we still have a plus or minus. Okay, so we were able to alleviate the need for the root up above here in this starred equation, or identity. Okay, but we have not yet decided if we should have a plus or a minus here, or does this depend on the angle? Sometimes a plus, sometimes a minus. Okay, or it could be a plus sometimes and a minus other times, or who knows. All right, so our next task is to see whether or not we need the plus or minus. Okay, I think creating a clean screen for the next series of steps is going to be helpful. So let me do that, and I'll be right back. All right, well, let's take a look at this little chart, which I find to be handy. Okay, we know from our previous screen that tangent of theta over 2 is equal to either positive 1 minus cosine theta over sine theta, or the negative of that expression. Okay, and what we would like to do is to see if we can say for sure which one, positive or negative, or it may resolve any question involving maybe whether it's plus part of the time and minus other times. Okay, all right, so let's just examine how this goes in the 4 quadrants. Okay, so sine and cosine have a period of 2 pi, that is one full revolution, 360 degrees. The tangent function actually only has a period of 180 degrees, or pi radians, but tangent theta over 2 extends that period to double its length. Okay, so let's consider what happens in all 4 quadrants for these functions. And if we can get the signs, that is SIGN, of each of these expressions on the left and right to match in all 4 quadrants, then they're going to match all the time. Okay, so let's see. So in the first quadrant, tangent of theta over 2 is going to be positive. Okay, now let's take a look at what this expression in parentheses will be in the first quadrant. Well, cosine theta is always between negative 1 and 1. In the first quadrant, it's positive. Okay, so we have 1 minus a number that is never going to be larger than 1. So the 1 minus cosine part is positive. And then, of course, in the first quadrant, the sine theta is positive. So positive divided by a positive gives me a positive. So in the first quadrant, we know that we can say that we have a plus sign for the plus minus. Okay. Second quadrant, well, the tangent theta would be negative in the second quadrant, but since it's theta over 2, okay, theta over 2 is still a first quadrant angle. So positive there. Okay, second quadrant. Okay, well, sine theta, let's start with that. That's positive in the second quadrant. What about 1 minus cosine theta? Well, cosine theta is actually negative in the second quadrant. So I have 1 subtract a negative number. That's going to be a positive number. Okay, so still positive there. Check. The signs match. So again, I can rely on the positive of the plus or minus. Okay, now if I go into the third quadrant, the sine of tangent theta over 2 is going to be negative. Okay, so in other words, for angles between 180 degrees and 270 degrees divided by 2, you get a negative for the tangent. Okay, all right, now what about this ratio, 1 minus cosine theta to sine theta? Well, in the third quadrant, sine theta is negative. In the third quadrant, 1 minus cosine theta is still positive. Cosine theta is negative, so 1 subtract that negative gives me a positive. Well, positive over negative is negative. Once again, the signs match. Okay. In the fourth quadrant, let's do the same thing. The sine of tangent theta over 2 is going to be negative. Okay, now tangent theta, the fourth quadrant, may be a different question. All right, but we're talking about theta over 2. All right, so angles between 270 and 360 degrees, take half of that, any angle in that range, I think you're going to get a negative for tangent theta. Okay, now what about our ratio here, our identity on the opposite side? Sine of fourth quadrant angles are negative down there. And then 1 minus cosine theta. Well, cosine theta is back to being positive, but it will never exceed the number 1. Okay, so that subtraction is always going to be a positive. So we get a ratio of negative here. The signs match. Okay, so in other words, this plus or minus here is always going to be a plus. Okay, so what we can say for sure now, tangent theta over 2 is identical to 1 minus cosine theta over sine theta. Okay, so we can be absolutely certain about that now, choosing the plus in our plus and minus, plus or minus. Okay. All right, now there is another option we could have pursued at the beginning. Okay, and you will recall at the beginning of our video, we took the starting of the previous identity, the first identity for tangent theta over 2 that had the plus or minus and also the root, and we multiplied top and we took the square, and then we multiplied top and bottom by 1 minus cosine theta. We could have done the same thing, multiplying top and bottom by 1 plus cosine theta. And if we had done that, we would have obtained this identity. Okay, now it also would have had a plus or minus if we had taken the square root of something that was squared, perfect squares on both sides. And then we could have gone through this same whole procedure again. Okay, and then it works out the same way. You can either trust me, or rather than trust me, I would encourage you to work that out on your own for this other option. Okay, so there are actually 3 identities for the tangent of a half angle, the one from the previous video and the previous screen, and then the 2 down here. Okay, in my work, I generally find that these 2 are a little bit simpler, easier to deal with because they don't have the root. They do have some pitfalls, but you're just always going to have those no matter what. But of course, you'll have to decide in whatever sort of work you need those for. Okay, that's going to do it for us this time. I hope you've enjoyed the video. Hope it's been helpful. Thanks for hanging around with me here on the channel, and hope you can check back soon and see some new videos. Maybe go back and watch some that you haven't seen yet. I would love it if you subscribe to the channel. Share this video with your friends and classmates, and hope your courses at school are going real well.